Hi friends, in this video I am going to make iupac naming of organic compounds really easy for you. Questions on naming of organic compounds always comes in exams. So I am going to share some tips and tricks of how to write the iupac name. I hope after this video you will find the iupac name as easy as writing your own name. And if you like this video, do share it out with your friends. And don't forget to try the quiz and the top 3 questions on this topic. Links are given below the video. There are some important rules that we need to follow for iupac naming. I'll show you the rules with the help of some examples. I recommend you to sit with a pen and paper. So let's go ahead and do this iupac naming together. Let's start with this simple example. So what do we have here? To name this compound, you need to first find the longest continuous carbon chain, which is this 2 carbons here. Now go ahead and number it forward and backward. Now why do we do the backward numbering? We'll discuss that later in the video. As you can see, this compound has 2 carbons. So what is its name going to be? Remember, there's a table. If there's 1 carbon, then the name starts with meth. 2 carbons, the name starts with eth. 3 carbons, it will start with prop. 4 carbons, bute, and so on. So the name of this compound will start with eth. And what type of bonds are there in this hydrocarbon? So you need to look at the bonds between the carbon atoms. And as you can see, there's only a single bond here. So this hydrocarbon is an alkane. So the name will be ethane. So that is the iupac name of this compound. It's ethane. So what did we have to do? Look for the longest continuous carbon chain, number it forward and backwards, and find the name based on it. It was eth. And since there are only single bonds, it's an alkane. So it's going to be ethane. Now let's go ahead and take a look at this example. So let's apply the same rules. We are going to find the longest continuous carbon chain, which are these 3 carbons, and we'll number it forward and backwards. So 3 carbons means the name is going to start with, that's right, prop. And is this a propane? No, because there's a double bond here. So there's a single bond between these 2 carbon atoms, but there's a double bond between these 2 carbon atoms. So it's an alkene. So the name is going to be propene. And if we had a triple bond here instead of a double bond, what will the name be? That's right, it would have been propyne. Okay. So what we learnt here is that you need to look at the longest continuous carbon chain, look at the number of carbon atoms once you've numbered it forward and backward, find the name based on the number of carbon atoms and also the type of bond for these hydrocarbons. Let's take a look at this example. What will be the iupac name of this compound? Again, let's find the longest continuous carbon chain, which is this one. And let's number it forward and backwards. So it's a 5 carbon chain, and we are going to do the forward and backward numbering. So 5 carbon means the name is going to start with pent, right? And since there are only single bonds between the carbon atoms, this is an alkane. So what is the name? It's going to be pentane, right? So this is a simple one. But now let's say the 5 carbon atoms are arranged in a cyclic structure, something like this. And to fill in let's fill in the hydrogens so that carbon has all the 4 bonds satisfied. So 1, 2 and 2 hydrogens. Same way here. So what will be the name of this cyclic compound? So the cyclic compound, the name starts with the word cyclo. So remember, it's going to be cyclo, not psycho. And since there are 5 carbon atoms here again, it's going to be cyclopentane. Pent because 5 carbon atoms and only single bonds. So it's a cyclopentane. Now let's take a look at this compound. So this also has 5 carbon atoms, but remember, we need to find the longest continuous carbon chain. So it's going to be this one. You can't go up like this and come down. So let's number the longest continuous carbon chain. And as you can see, there are 4 carbon atoms here. So if we ignore this attachment of CH3 for a moment, what's the name going to be? 4 carbon means it's going to be but. And since there are only single bond between the carbon atoms, it's a butane. So that's simple. Now let's look at this CH3. So CH3, as you may know, is an alkyl, because the definition of alkyl is it's an alkane minus 1 hydrogen. So if this had been CH4, but we've removed a hydrogen, so we have CH3. So if it was a CH4, the name would have been methane, 1 carbon atom, right? But this will be now called methyl, right? Because it's an alkyl. And the alkyl name comes in the prefix. So you have to put it over here in the beginning of this name. So we have basically a methyl butane here. But now this methyl could have been here, or it could have been here or here. So we also need to give its position. And the position is based on this numbering that we have done. So what number should we give it? It's on number 2 or 3. But you need to choose the smallest number. So it's going to be 2-methyl butane. Okay, so that's the name of this compound. But let's say we had another CH3 over here. So can you guess what will be the name here? So let's work it out again. First, the trick is ignore these attachments. So it's basically a butane. And we have 2 methyls in here. So that's going to be a dimethyl. And we also need to specify the positions of the methyl groups. So here you can't say, I can't choose 2 and 2 because I want to choose the smallest number. You either have to go with the top, the forward numbering, or the backward numbering. So it's going to be 2, 3. Or if you use the backward numbering, it will be 2, 3. So both the numbers are same. We have to choose the smallest number. So it's same anyways. So we are going to write it's 2, 3 dimethyl butane. Now note some important points here. Between the number and the letter, there's always a dash, as you can see here or here. So between the number and a letter. And if you have 2 numbers like here, there's a comma in there. Can you see the comma? So this one would be 2, 3 dimethyl butane. That's the iupac name of this compound. Now let's take a look at this compound. So what's interesting here is that there is a chlorine in here. But again, first ignore the chlorine and look at the longest continuous carbon chain. So let's go ahead and number it forward and backward. And we have 1, 2, 3, 4, 5 carbons. And I'm going to number it backwards also. So if we ignore chlorine, what is the basic name here? It's 5 carbon. So that's a pent. And as you can see, there are only single bonds here. So it's a pentane. Now this chlorine is a halogen. And so that's our functional group here. So we have the halogen functional group. And remember, for halogens and for the alkyls that we had done, the name goes in the prefix. So it's going to be a chloropentane. Not chlorine pentane, it's chloropentane. So that's the way IUPAC name is done. And we also need to give the position. So what position of chloro should I give here? Is it going to be 5-chloro? No, it's 1-chloro, because we'll choose the nearest number, the smallest number here. But there's no need to actually write 1-chloro here, because the number 1 is not necessary. So simply the name is going to be chloropentane. But if the chlorine was here, then the name would have been 2-chloropentane, right? Now let's take a look at another example. So let's say again we have 5 carbons here. And we have a chlorine in here, a chlorine in here, and let's say a bromine in here. I'm not drawing all the other hydrogens. So again, we'll number our carbon chain forward and backwards. So it's 5 carbon. We'll ignore this for a moment. So that's the simple way to do it. So you'll have a pent and only single bonds, pentane. Now again we have some halogens in here. So there are 2 chloros and a bromo, right? Now there's another rule that comes in here when you have a bromo and a chloro, you need to go in alphabetical order. So B comes before C. You shouldn't consider the dichloro. The D is not important. We are comparing bromo and chloro. So the name bromo will come here first. So there's a bromo and there's a chloro. Sorry, dichloro, right? So there's a bromo and dichloro. But we also need to give the numbering. And remember, we need to choose the smaller numbers. So we won't go for this scheme, we'll go for the backward scheme. So you can see that there's a 1, 2 dichloro and a 3 bromo. So I'm going to rewrite this name again as, so let's cancel this out. It's going to be it's going to be 3 bromo, right? So the bromo is at position number 3. And after that we have 1, 2 dichloro, correct, and pentane. So note these things carefully, that between the number and the letter, you can see there's a dash. Between the numbers, there's comma, and there's a number and a letter here. So again a dash, and we went in alphabetical order. Bromo B came before chloro. So you can see it's a 3 bromo 1, 2 dichloropentane. All right, let's try the next one here. So what's the name going to be? Again, let's number the longest continuous carbon chain. So we have 4 carbons here. So the name will definitely have but in it, and there's a double bond. So is this compound's name going to be butene? No, because the double bond is not at the first position, or over here if you counted the 1 from here. So we also need to give the position of the double bond. So how do we do that? The double bond is between 2 and 3. So we'll choose the smaller number and say the double bond is at position 2. So the name is going to be but-2-ene, because we are giving the position of the double bond. Sometimes you may see this compound written as 2-butene also, but usually this is the recommended style where we give the number in the middle here. So it's 2-ene, but-2-ene. Okay. Now let's try this compound. So here what do we have? We have a 5 carbon chain. And there are some interesting triple bonds here. So you can see that there are 2 triple bonds. So is this going to be a pentyne? No, because there are two bonds. So first the name's going to start with pent because there are 5 carbon atoms here, and it's a diene because there are 2 triple bonds. So I'm going to write that here. It's a pent diene, but I need to specify the position of the triple bonds. So what's the position going to be? We can say the triple bond is between 2 and 3 and 4 and 5, but that's using the bigger numbers. So let's go for the smaller numbers. So we'll start counting from here. So the triple bond is between 1 and 2 and 3 and 4. So we'll use these position numbers because we are saying the triple bond is at position 1 and position 3. So the name is going to be pent 1, 3 diene. And again, between the letter and the number, there's a dash, and between 2 numbers, there's a comma in here. All right, let's name this guy now. Now what's interesting here is there's the OH functional group. So this is an alcohol. But again, to simplify things, we are going to ignore OH and look at the longest carbon chain here. So let's number it here. Forward and backwards. So there are 4 carbons. So basically the name is going to be a bute. It's going to start with bute. And if the alcohol wasn't there, the name would have been butane. But you know that alcohol and other functional groups that we are going to talk about, their name comes in the suffix. The prefix was for alkyls and the halogens. So this alcohol name will come in the suffix, and the name ends with OL. Now when you add OL, you need to remove the E. So this OL gets added to the name, and the name basically becomes butanol. So remember, the E is removed and we attach the suffix OL. And what is the position of butanol? It's at position 4, but we'll choose the number 1 here because that's the smallest number. So it's basically butan 1-ol, or basically butanol, because we don't have to write the number 1. Now let's say the OH was at a different position. So let's say we had something like this. And the OH was here, and rest of course are hydrogens. So what will be the name of this compound? Again, we'll number our longest carbon chain. Right? So this will be bute. It will start with bute, and the name would have been butanol, but the position of OH is on 2 because we'll not take 3, that's the larger number. So it's basically a butan 2-ol, or sometimes you might find it written as 2-butanol, but usually this is the preferred way of numbering it, butan 2-ol. Now let's try to name these 2 compounds. Earlier we had seen the alcohol functional group. Here also there's a functional group. So do you know the name of this functional group which has C double bond O and H? That's right, it's called aldehydes. And what is the functional group on this compound? This is our functional group, and it's called ketone. So both the functional groups have C double bond O on them. So what's the main difference here? The aldehyde group is always at the end. So either on this carbon or it could have been here. Okay, because it ends with an H. But the ketone group is interesting because the ketone group must have at least 1 carbon on both the sides. So that's an important difference to remember, because the functional group decides the property of the compound and of course its name. So let's try to name this guy. So again we'll apply the rule and look at the longest carbon chain. And one important point to remember is even the functional group carbon needs to be included in the counting. Okay, So it's 5 carbons, including this one. And we'll also reverse number it. So if this functional group wasn't there, it would have been a pentane, right? The compound would have been 5 carbon pent and only single bonds are there if we ignore the functional group. So it would have been pentane. But the rule is to delete the E and add the suffix in the name for this functional group. And it's an aldehyde, so we add the Al to it. So what will be the name of this compound? Pentanal. And it's at position 1, the smallest number. So it's basically pentan 1-ul or simply pentanal. Okay, is that clear? Now let's take a look at this compound. So here we have 3 carbons and we'll include the carbon of the functional group. So it's a 3 carbon chain. So the name will be propane, right? If we ignore the functional group. But again the rule is we'll remove the letter E and add, for the ketone we need to add one. So what's the name going to be? Propanone. Now you might be thinking we need to include the number also, right? Because the functional group is at position 2. So you might be thinking the name will be propan-2-one or 2-propanone. But no, the name is simply propanone. Why? Because 1-propanone or 3-propanone is not possible. Because if I move this ketone group to this side or this side, if it becomes on the N carbon, what will it become? It will be an aldehyde. So only possibility with 3 carbon is 2-propanone. So we simply write it as propanone. Now let's take a look at this example. I've written this in a condensed form because the whole structure with the hydrogens is not expanded here. Again, you should look for the functional group, and can you see it? It's COOH. So this is a carboxylic acid. I'm just going to write simply acid here. And again, let's count all the carbons in our longest carbon chain. So we have 5 carbons, and remember we need to include the carbon in the functional group also. And let's reverse number it here. Okay. So if we ignore the functional group, the name would have been pent, because 5 carbons and all have single bonds between the carbons. So it would have been pentane, right? But this functional group's name will come in the suffix. And for acid, it's going to be, the suffix is going to be oic acid. That gets added. So we are going to delete the E and add oic acid here. So what is the name of this compound? It's going to be pentanoic acid. Right? And we don't have to give the position of this functional group because it's at position 1. So it's pentan 1-oic acid or simply pentanoic acid. Now let's say we have a chlorine over here. So I'm going to remove one H and let's add a chlorine in here. So what will the name of this compound be? So it's basically a pentanoic acid and the halogen comes in the prefix. So it would be a chloropentanoic acid. But we need to do the numbering, right? So what number should we choose? If we look at the smallest number, we will think of writing as 2-chloropentanoic acid. But that's the wrong answer. Let me explain you why. Because in this compound, can you see that there are 2 functional groups, an acid and a halogen. And then there's an important priority order that we need to follow. So let me write down the priority list here. So what is the priority list that you need to know? So we have, on the top priority, we have the acids. So that's COH. Then we have aldehydes, followed by ketones, then alcohols, then you have the triple bond, double bond, okay, and then you have the halogens, so things like chloro, bromo, right, and then you have the alkyls, so things like methyl, ethyl. So these are the highest priority, so this is our priority list here, and the top ones are at higher priority than and this one is at the lowest priority. An easy way to remember is, this one has the most atoms, 1, 2, 3, 4, so that's the top priority here. This has 3, this has 2, and this one doesn't have carbon. And you know in organic chemistry, carbon is the king. So that's alcohol, then you have the triple and double bond, followed by this functional group of halogens, and then the alkydes. And remember, these guys were added as prefix in the name. So the prefix fellows come down at the priority list, and all of these affect the suffix of the name. So you can note down this important priority list, and the numbering will be based on that. So let's apply this for our compound here. So we have acid and a halogen. So according to our priority list, acid gets the top priority. So he wants position number 1, right? So we need to follow this numbering scheme, not this one. And the halogen is at position 4. So basically, what is this compound? It's a 4-chloropentan 1-oic acid, right? So we can simply write that as, instead of a 2-chloro, it's going to be a 4-chloropentan, but I won't write 1 because it's not needed. So it will just be 4-chloropentanoic acid. So this is an important thing we've learned, that when there are multiple functional groups, we need to apply a priority list to determine the numbering here. Here's another example for you. Why don't you pause the video and try writing the IUPAC name yourself for this one. So what is the answer you got? Is it 2-ethyl and 3-methyl (1, 2, 3, 4, 5, 6) hexane? So is this your answer? Actually, this answer is wrong. So what is the right answer here? Let's take a closer look. So if you look carefully, this is not the longest continuous carbon chain. Why? Because this one has 6 carbons, but if you go like this, then can you see there will be 2, 3, 4, 5, 6, 7 carbons. So the longest continuous carbon chain is this one. So it's easier if we expand this one and write it as, right? So I just expanded the ethyl there for you, and let's number our longest carbon chain here. So 4, 5, 6, 7, and again backwards, 1, 2, 3, 4, 5, 6, 7, right? So this is not basically a hexane, it's a heptane, right? And what are the attachments in front of this name? Because you can see the attachments or the substituents we have here are 2 CH3s, right? So that's basically, and you know CH3 is the alkyl group, so it's a dimethyl. So we have a dimethyl in front of the name here, the prefix part. And what are its positions? It's at position 1, 2, 3 and 4 if we number this way. So 3 and 4 here. And if we go this way, it's at 4 and 5. So again, we'll choose the smallest number, which is 3 and 4. So the name is going to be 3,4 dimethyl heptane. So that's our correct answer here. Okay, let's try this one now. Here we have 4 carbons, and can you see the functional group here? What is the functional group? That's right, it's a ketone. Because you have C double bond O and carbon on both sides, right? So let's number our longest carbon chain. 1, 2, 3, 4 and reverse 1, 2, 3, 4. Okay, so if we ignore the functional group, it would have been a butane, right? But there's a functional group in there, so I'm going to delete the E, and in ketone the one gets added, so it becomes a butanone. And what is the position of the functional group? It's at position 2. So that will make it a butan 2-one, right? But there's something interesting here. If you write this name, it's probably fine, but strictly speaking, if you look here, if I shift the double bond over here, then what will the name be? It's not going to be butane 3-one. Again, now we'll take the smaller name, a smaller number I mean. So it's again going to be butan 2-one. So just like propanone, for 4 carbons also, only one ketone is possible, which is butan 2-one or simply butanone. So this is the best answer here, that the name is just butanone, because you can't have the double bond O at carbon 1 or 4, because then it will become an aldehyde. It will be at the end carbons. And if you put it at 2 or 3, it doesn't matter. The name is the same, butan 2-one or simply butanone. And here's our final example. For this one, I want you to write the iupac name yourself. So do let me know your answer by putting it in the comments below. I hope the iupac naming is crystal clear to you now. Here is a summary of the rules that we learnt. The first thing is to find the longest continuous carbon chain and remember to number it forwards and backwards. Then you should check for functional groups, whether they are double bonds or triple bonds present in the compound, and add the name as the prefix or the suffix. And remember to use the priority list that we talked about, the alphabetical order, and using the smallest number to give the position numbers. So go ahead and use all these rules and find the answer for this compound. And do let me know your answer by putting it in the comments below. And if you found this video useful, do share it out with your friends. And if you haven't subscribed to my YouTube channel already, hit the subscribe button right now. You can also check my Facebook page and do check out my website, manochaacademy.com, for the quiz and the top 3 questions on this video. I'll put the links in the description below. Thanks for watching.